Okay, so for the question, for problem one, it says the directions say to state the problem statement clearly. So a Carnot heat engine receives heat at 9xyk and rejects the waste heat to the environment at 3yxk. The entire work output of the heat engine is used to drive a Carnot refrigerator that removes heat from the cooled space at negative 15 Celsius at a rate of 250 kilojoules per minute and rejects it into the same environment at 300K. So now the instructions tell us to draw a schematic on the screen and determine what's going on. So let's start off. For my start, we're gonna start at, well, first of all, what's going on here? Work out is equal to work in. Energy out is equal to energy in. This is an important thing to familiarize ourselves with the beginning. So it is saying that we are starting off at 923K. This was my custom one. So we are taking this heat and transferring it into our heat engine. So heat engine. We'll talk about these arrows first, but what I like to do is talk about the process first, what's going on, and then I like to implement these steps. So sort of like big picture stuff first, and then we can get into the values. So it's saying that we're going from the heat, or supplying this heat engine, and it is saying that it is rejecting it into the environment at 300K. So it's going from the heat engine and rejecting it into the environment at 300K. Well, what else do we have here? We have a refrigerant. Well, this is going to be taking out heat from our engine, allowing it to not overheat. So we must add this arrow here so that this heat engine can cool down. This is directly connected to our environmental heat. And it's saying that it is helping us cool down this heat engine, negative 15 degrees Celsius. And this arrow is pointing downwards. So what is going on? We have heat being supplied to the heat engine, going out into the environment, and then this refrigerant right here is taking the heat and cooling down our engine. So this QH here, this is the heat absorbed. This is the heat that's being absorbed by the heat engine right here. And my calculations in my problem will give you the values for these, but I'm just gonna do what the problem is saying. The problem is asking for. So this QH, like we said, is the heat being absorbed into this. Now this arrow right here is rejecting the heat, so QL would be our heat being rejected. Right here, remember that we are having this refrigerant to help cool off our heat engine. This value out here is going to be Q prime H, which is essentially what's helping us cool down the heat being absorbed. So this heat absorbed will change due to the cooling. This QL prime, considering that this is QL is what's rejecting it, and this is the rejection from the refrigerant. So not only does our heat engine reject things, but also does our refrigerant reject things as well. So here, what we came up with out here, our work out that's coming out has to equal our work in. So whatever comes in must leave out equally. So energy in equals energy out, same as work in and work out. Something else to add. We are going to, this is basically what's the most important part in solving our problem. We need to evaluate what's going on. We have the heat engine, we have the refrigerant. we have this heat going in here, we have the refrigerant helping us cool out, but we must remember that our work out equals our work in. Although there is an environmental, it rejects it into the environment, doesn't matter. This will stand as is. So that is what problem 1 is asking for in the question. The values for these are shown in my my PDF if you guys want to check it out. I'll link it into the group chat, but yes, this is the flow process.